Now we are going to do the lab experiment on combinational logic circuits. So take a look at experiment 1. We are going to prove that the two Boolean expressions AB or AC and A bracket B or C are identical. This is the distributive law. So on my right hand side is the multisim. Let's place all the components first. So you can get most of the gates from miscellaneous digital. So we place all gates and we look at the circuit diagram. There are 3 AND gates. One, two, three AND gate, and still need to add one more OR gate here. And we also need 3 switches, single pole double throw switch. It is under basic switch. So we will place 3 switches because there are 3 input variables here. And we also need the sources, ground. Now remember to use a digital ground and VCC. We also need to call out the indicators, which is the probe. You can choose any color you like to test the output. Okay, we have all the component that we need. We need to flip the switch horizontal. Let us adjust the component. Okay, we connect. So if you look at the circuit, first we want to complete the upper part of the circuit, which is A bracket B or C. So there are 2 input will connect to the input of the OR gates. So the other input is here, B or C. So let me change the key. We name the first switch as B, so we can use press B key to toggle the input. And the second switch is C, and the third one is A. Okay, so we have finished B or C. Maybe I'd like to add the text so you can see. Okay, we finished this part. We'll continue to complete the drawing. Right, another input is A, so I'm going to bring this switch slightly nearer to the gate. So this is the output for A bracket B or C. So we have completed the first the circuit for the logic expression A bracket B or C. Now I'll continue to do the to complete the bottom part of the circuit diagram, which is AB or AC. So this is the AND gate, connect to A, and the other input is B, and the other AND gate, the 2 inputs are A and C. C is here, right? So you have to check and make sure the connections are correct. Okay, and the 2 input will connect to the OR gate. Okay, here will give you the output of AB or AC. Now, I have to connect the VCC to the switch as well. One end of the switch, the top part of the switch here, this is single pole double throw switch. So the upper contact point here, I will connect to VCC to make it consistent. Okay. Right, I move this end nearer here so I will not short the VCC to ground. And the lower part of all switches will be connected to the ground. So let's double check. The first circuit is A bracket B or C. So we have this OR gate is connected to B, C, and output go to the input of the AND gate end with A. So it's correct. Now the bottom part of circuit is A, B, or AC. So let's check again. This is A, and the other input connect to B. And the bottom AND gate, both input, one from A and the other input from C. So now we are ready to do the simulation. Now, before we do the simulation, maybe we should look at the truth table first. Okay, so you should be able to fill up the truth table. First, you double check with the result of the simulation. Okay, let's analyze this logic expression. Now, take a look at the right columns here, A and bracket B or C. Now, you know if one of the input is 0 for the AND gate, the output will be 0. So we can look at the input here. If A is 0, the output will be 0. So you can see that this A is 0, this A is 0, this is 0, and this 0. Okay, so for all these 4 input combination, we can just write down the output here, 0. This is 0 as well. Okay, let me use my pen. 0, 0. Okay, now let us look at the second input combination, 0, 0, 1. Now, because although A is 1, but the B or C both 1, so output will be 0 as well. Okay, one of the product term, if one of the input is 0, output will be 0. So 0 or 0 will give you 0. So 0 and with A will give you 0. Okay. Now, how about this input combination? A is 1, but in the OR term, B is 1, so output will be 1. Okay, and 1, 0, 1, again, one on the input of OR is 1, output will be 1. 1 and with 1 will give you 1. And last one definitely is 1. Okay, so if AB or AC is the same as A bracket B or C, when we run simulation, the same input combination come in, both should be either turned on or turned off. So let's do the simulation now. Now take a look at right window. This is the edit window for multisim, and you can see there is a run button here, green, so we are ready to do simulation. Before we do the simulation, maybe we should set all the input to 0. So now as I already changed the key to this switch change to the key. The first switch is B, second C, and third A. So we can use all this key to toggle the input, whether switch to VCC or the ground. Okay, so for the first set of combination, all 0. So I will toggle B to 0, and then C already 0, and then A to 0. So I set the initial input to all 0 before I run simulation. You can see the first row here, all 0. So I'm going to run simulation. You can see the output 0. Okay, so it's correct, same. Both output 0. And I continue the second input 0, 0, 1. Only A is switched to 1, so I just press the key A. Again, you can see output 0 as well, so it's same. Third input 0, 1, 0. So A now is 0, and only B is 1. So I will press key B, go 1. And again, the output same as what we have analyzed previously. Next input 0, 1, 1. Only C is 0. A and B both 1. So now I only need to turn on A. And you notice that output now will change to 1. Again, it matched. The next input is 1, 0, 0. C is 1. A and B both 0. So I will switch the B to 0 first and A to 0. And I switch the C to 1. And you notice that the output both give 0. Next input is 1, 0, 1. Only B is 0. So B now is already 0. C is 1. And I just need to change A to 1. And you notice that the output, same, both 1. Same as what we have just analyzed. The next input 1, 1, 0. A is 0. So I switch A to 0. And B and C, let me check B. Switch to 1. And you notice the outputs will equal 0, same as in the table. Lastly, all 1. Only A need to switch to 1 because B and C both already 1. So I press key A. You notice the output now changed to 1. So you can see that it proved that the both output, these two logic expressions are equivalent and both output the same. So I will fill up this column, just copy from here. 0, 0, 0, 1, 0, 1.